Maximum versus effective context. In controlled tests, model performance fell as the input grew even when the relevant information was retrieved perfectly. I'm Mehrdad. In this video, I'll give you 5 production controls for effective context: budget, select, place, maintain, and verify. Maximum context is the provider's hard admission limit for a particular model and endpoint. Your operational limit is lower. It is the largest request your system allows after reserving room for reasoning, tools, output, and safety headroom. Effective context is narrower again. It is the longest input range where the workload still meets its quality, latency, cost, and risk targets. That threshold is not a permanent property of the model. It changes with the prompt, the evidence, the task, the model version, and the context strategy. Capacity is specified by the provider, while effective context is established by your evaluation. Consider a customer asking for a refund 45 days after purchase. The current policy, version 4, requires both manager approval and a past fraud screen. But retrieval also finds version 3, where a supervisor could approve the same exception directly. Both passages are topically relevant. The obsolete one uses language that matches the request more closely, and the fraud screen is still pending. The complete prompt fits, retrieval succeeded, and a cache may even reuse the stable prefix. Yet the model recommends approval from the wrong policy. This is not a window size failure. It is an admission, freshness, contradiction, and authority failure. If this is useful, like the video and subscribe for the rest of the context management series. Long context tests answer different questions. A needle test asks whether the model can locate an obvious item. Ruler adds retrieval, tracing, and aggregation tasks across increasing lengths. No Lima removes easy lexical overlap. Logic haystacks replaces harmless padding with material that looks relevant to the reasoning problem. Helmet moves closer to application behavior, with retrieval, citation, re-ranking, summarization, and generation tasks. These evaluations are useful, but none reproduces your production distribution. Needle success diagnoses addressability, but it does not certify a refund decision, a compliance review, or an enterprise search workflow. Use public benchmarks to choose failure modes, then build a workload evaluation that can reject your own design. Why can a larger accepted input become less useful? Position is one documented factor. Important evidence may be used differently depending on where it appears, but there is no universal position curve across every modern model and task. Interference also comes from plausible distractors, semantic near matches, duplicated facts, cross-document dependencies, and direct contradictions. In our refund case, the obsolete policy is not random noise. It is coherent, relevant-looking, and almost correct. That makes it more dangerous than an unrelated paragraph. The practical goal is not to maximize relevant-looking tokens, but to minimize unresolved competition around the decision. That leads to the first control. Budget the envelope before deciding what enters. Start with the model's capacity, then subtract reserves for everything that must happen after and around the input. Reserve room for the visible answer, reasoning or thinking tool calls, structured output, protocol overhead, and a safety margin for variation. Do not copy one reserve percentage across applications. Estimate each reserve from real traces, then set limits from the tail rather than the average. Before each call, count the provider-rendered request exactly. That means messages, files, images, tool definitions, and other structured content. Not only the strings in your database. OpenAI, Anthropic, and Gemini all expose request-aware token counting or usage information, though their interfaces differ. A request that technically fits can still be operationally over budget. Track the breakdown by category, and reject, trim, or reroute before the hard limit makes the decision for you. Once the envelope is fixed, every item must earn admission. Start with mandatory authority, the current policy, the task, the success criteria, and the output contract. Then add current state, unresolved decisions, and only the evidence needed to resolve them. Each evidence block should carry a source identifier, a version or effective date, a retrieval time, an access class, and a trust classification. Mark superseded and contradictory material explicitly. In the refund case, policy version 4 is authoritative, version 3 is obsolete, and the pending fraud screen is unresolved state. Do not ask similarity ranking to decide authority. Filter expired and unauthorized material first, then rank what remains. Keep evidence for one claim locally coherent instead of scattering it across the window. Test important evidence in several positions, because position sensitivity can vary by model and task. Selection decides what enters, placement decides what competes nearby, and neither one replaces provenance. Prompt caching reuses stable prefixes, so repeated requests can reduce prefill cost or latency. That is valuable when instructions, examples, files, or tool definitions stay identical. But cached tokens still belong to the model visible input. A cache hit does not remove obsolete evidence, resolve a contradiction, improve attention, or expand the context window. Cache is an execution optimization, not a context quality control. Measure cache reads and writes separately, and keep the cached prefix stable only while its policy and authorization assumptions remain valid. As the interaction grows, maintenance has three distinct operations. Editing removes material that is no longer useful, such as old tool results or duplicated observations. Compaction replaces detailed history with a smaller continuation state or structured checkpoint. Retrieval keeps durable material outside the active window and brings back selected evidence when needed. These operations are not interchangeable. Editing can delete something later required for audit. Compaction can lose a qualifier, an unresolved exception, or a source boundary. Retrieval can miss a dependency that only appears across documents. Provider-managed context editing and compaction can buy runway, but they do not make the transition lossless. Version every checkpoint, retain recoverable originals, and regression test what survives. Maintain context before the boundary rather than after truncation. The question is not only what can be removed, but what the next decision must still know. Context also mixes information with different trust and permission levels. Application policy may be privileged. Customer text, retrieved pages, uploads, and tool results are untrusted data, even when they look like instructions. Separate those classes in the request so the model has the clearest possible hierarchy. Then build the enforceable boundary outside the model. Validate schemas, check tenant access, authorize each consequential action, and require approval where policy demands it. In our refund case, the model can recommend an escalation, but it cannot grant itself permission to issue the refund. Delimiters and role messages help interpretation, while external controls create authorization. The final control is verification. Build tests from real workload traces and controlled counterfactuals. For support, vary policy age, contradiction load, evidence position, and missing customer state. Measure decision accuracy, groundedness, citation precision, abstention, and stale evidence rate. For compliance or finance, add temporal validity, cross-document dependency, and authorization failures. For enterprise search, measure evidence recall, context precision, and whether the answer survives semantic near matches. For analytics, test long tables, aggregation, and citation back to source cells. Slice every result by input token range, position, distractor load, model version, and context strategy. Track latency and cost per successful task, rather than per request alone. The longest slice that satisfies every required service target is your application's effective context length. When the model, the prompt, or the data distribution changes, measure it again. Before production, pin the model and endpoint, count the rendered request, and reserve the full operating envelope. During assembly, admit evidence by authority, freshness, provenance, and task need. Mark contradictions and superseded facts instead of hoping the model resolves them. Place related evidence coherently while testing position rather than assuming one universal order. During operation, log the context manifest, maintain state before the boundary, and enforce permissions outside the model. Then verify quality, safety, latency, and cost across the workload's real-length distribution. Budget, select, place, maintain, and verify. A large window is available space. Effective context is an engineered decision. If this video was useful, subscribe to Multi-Agent Academy and connect with me on LinkedIn. I'll keep publishing evidence-backed work on agentic systems. Next, we'll show why your tool list is context and how to expose capabilities without loading the whole catalog.